Hello and welcome to 5-Minute Math. Today we are looking at the 7th grade concept of solving scale problems. This is standard 7.5C in the great state of Texas, and we are using item number 35 off the 2017 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and then we will look at our answers together. So we have the distance between two cities on a map is 3.5 centimeters, but we know that maps have keys. And here we go. The scale here shows that 1 centimeter represents 20 kilometers. So what is the actual distance between these two cities in kilometers? All right, so there's two different ways to set this up. You should be seeing the fact that we've got three numbers with labels: 1 centimeter, 3.5 centimeters, 20 kilometers. Then we got a fourth label without a number, and that the labels match: centimeters, centimeters, kilometers, kilometers. That means proportion. That's one way to solve it, and I find it to be the easiest, though there are some other ways to solve this. But there's even two different ways to set up our proportion. So we've got the scale, and we've got the actual, right? So that's one way we can set it up. So we could say our scale is 1 centimeter to 20 kilometers. So that's our scale that we get from our story right here. 1 centimeter represents 20 kilometers. Then we just need to match up the units. And so we say on the map, it is 3.5 centimeters. And so let's make that centimeters. There we go. We need to just match that up with X kilometers. That's what we're looking for. So we're matching up centimeters with centimeters, kilometers with kilometers. Another way to do that is just to write, instead of having the scale over the actual, right, we can just have the units together. So we could do like this. We could say 1 centimeter relates to 3.5 centimeters, and this 1 centimeter relates to this 20 kilometers over here, because that's our scale, and that goes over our X kilometers that we're looking for. So instead of having the scale over the actual, I had the scale across from each other, and I kept the units the same: centimeters, centimeters, matching up with kilometers, kilometers. Well, guess what? If we use our cross multiplication, it's not really going to matter. This is 1x, so 1x is really just x. So I just need to multiply 20 times 3.5. That's easy. 20 times 3.5. Over here, look, I end up doing the same thing. 1 times x is x. And I'm just ordering it slightly different. 3.5 times 20. But either way, you just need to take 3.5, multiply by 20. Let's do that. 3.5 times 20. So that is 0, 0. That's pretty easy. That is 10. All right, 70. So let me write this over here. Looks like I've got 700, but remember, I've got that decimal there, and that's probably the trick, if there is a trick in this problem, is that you've got one digit behind the decimal, so you need to put one digit behind the decimal in your product. And so instead of 700, the answer is 70. But we could do all of this and still get it wrong, because we still have to bubble it in. So we've got our answer document over here. There's no A, B, C, or D to choose from. So it's going to look something like this. You're going to have this thin column that is for your decimal point. There's nothing to bubble in underneath that. You've got 2 digits to the right, and you've got 4 digits to the left. You also have, off to this left, you've got a little plus minus, and you don't really need to use it unless you have a negative number. You can bubble in this positive if you want to, but it's also, numbers are just assumed to be positive unless you bubble in the negative. So we're good without that, and we just have to line up our 70 in the correct spot right here. Now, you do need to bubble in this 0 right here, but you do not really need to bubble in the 0.0. You can leave the tenths and hundredths blank, and that's our answer.